So, to be honest, I was very nervous because I'm following up Kelsey. And then Ron told me to think about it as Kelsey actually gave an opening note for us. So, thanks, Kelsey, for that. so, myself, Dilpreet, and he's my colleague, Anirudh. Yeah, let's go. So, what we'll be covering in this presentation today will be unveiling Clover, and then we'll be walking through a real-world rainbow deployment problem, which helped us tame our Clover monolith. So it stands for Clover operating system, as we call it. And then we're going to show a small demo on how we tackled our deployment of our monolith and how we used HAProxy Fusion Control Plane as a service mesh along with it. Then we see the demo and then some takeaways from it and the path forward. So what does Clover do? Dylan gave a small brief already about it, and we just don't take payments. We track inventory. We also manage employees with powerful apps and tackle everything about as online sales and also customer loyalty programs and what more. So Clover and HAProxy, we have an amazing working relationship with HAProxy from the past 10 years. One thing we love about them is 0 pages, 0 drama. And trust me, at Clover, we don't want any drama in our applications. And it has been a silent workhorse for us. Its seamless integration often goes unnoticed when we are talking about technologies and how to proceed further, because we know that part of our application is already covered because we have HAProxy with us. And its reliability, of course. So what's the use case here? So as I mentioned, we have a huge monolith, which we call as Clover operating system. And we took up a task on figuring out how we can containerize that. And this whole journey has been regarding that. So we went further from blue-green deployments or just canary deployments to think about something as many colors as we want. So we can go on from blue, green, red, yellow, whatever we need for our use cases. So I think most of you will be aware about traditional blue-green deployments. So blue deployment, as you all know, is like the latest, the most stable version of any application that is there, and it's being used by all the customers. And then we have a green deployment, which is the candidate for the next major release, and which all the customers will be eventually migrated to. And then we had a specific use case where we wanted to pin specific customers to specific versions or add a functionality just for those customers. And we have very traditional banks that we deal with, which are very careful about moving to a new version or changing their version. So we have to pin them sometimes to a specific previous version. So we came up with this idea, so why don't we have more colors to it, like blue, green, whatever, red, and so forth, so that we can pin some of our customers just to a specific version, and then they don't need to worry about any changes that we are doing in our applications going forward. So other colors deployment, just what I explained, this is for that. It can be a hot fix, it can be an experimental feature that we want to use for our application. So how HAProxy helps us in this is we are using HAProxy for weight-based routing. So you can imagine bringing in a new release and then adding a new weight, let's say 20% to start with, and then increasing it so on until it goes to 100, or we can keep it at 50, whatever we want. It helps us with SSL termination, and it brings in security, and also it helps us with the speed of our monolith. And then it also gives us the service mesh agility. So why we chose HAProxy Fusion Control Plane for this? I think in the first talk of the day, it was explained beautifully what HAProxy Fusion Control Plane can do. It supports multi-cluster management for not just north to south traffic, but also to east to west. So I'm not going to go over that a lot. And it gives us real-time configuration updates. It has a REST API interface, which is going to be instrumental for us going forward because we want to automate the process instead of making manual changes to the configurations, we want to codify that for our developers. And then it also provides console integration for dynamic backend server pools. And Kubernetes integration, that's for our future use because we use Kubernetes for our microservices. So next is going to be the architecture diagram. So you guys can see on the screen, so we have a TCP load balancer, which takes the traffic from the outer world. And then we have our Nomad cluster, which is blue, green, and red. So there are 3 versions of our COS monolith running. And on each of them, we are running a single HAProxy instance with 2 different front ends. 8080 is to take traffic from the GCP load balancer. And then on 443, we take traffic from the 8080 port. And you can see the arrows, which it can go to anywhere but based on the weight that we have defined. And then it talks over localhost to our monolith application. Ani is going to talk about it extensively in the video, so I'll skip over this part for now. And now we're ready for the demonstration. I'll let Ani take over from here.
Yeah. So let's quickly go over the Nomad platform and the applications that we are running on top of it. If you can start the video. Yeah. So in the Nomad cluster, we can see we have divided the cluster into 3 different groups. We have 3 blue Nomad nodes running, 3 green Nomad nodes running, and 3 red Nomad nodes running. In the job view, we have the same COS application that Dilpreet mentioned. We have 3 different colors and 3 instances of each of them. So we have 3 red, 3 COS, and 3 blue. Putting them together in the cluster topological view, we are going to run the COS blue jobs on the 3 Nomad blue clients, COS green job on the 3 Nomad green clients, and similarly COS red jobs on the 3 Nomad red clients. This is the same architecture that Dilpreet just covered. We're going to have 3 different versions running across the 3 different colors. So in the HAProxy Fusion Control Plane, now you can see right now we do not have any clusters. We just have the default cluster. There's nothing in the dropdown there. In the service discovery section as well, we do not have any providers configured. Right? So the first step is to go ahead and create a new cluster. And we are going to do that by running a one-time job on Nomad. We call it the FCP Bootstrap, Fusion Control Plane Bootstrap. This one's a custom-built container image, which is nothing but a Python script that runs, that fires off a bunch of REST APIs against the Fusion Control Plane server. Among the other configurations, the important ones are to note, the ones to note are the config file, which contains the Fusion Control Plane connection details, such as the endpoint, the authentication details, as well as the HAProxy license key, because we use the enterprise version. In addition to that, we are also going to provide some of the cluster details like the name, the fact that we want to store the generated bootstrap key in vault, and also the vault path. The important piece here is the service discovery integration with console. We're going to want that, so we point the console details, we provide the console details, as well as the token. And importantly, we are going to provide Fusion Control Plane with the template that it needs to use to generate backends dynamically. You can also see that we have several backend directives that we will want in our dynamically generated backend. Also note the name, the suffix for the name, which is going to be used to name the backend entirely. And lastly, the server lines, the individual server lines that we all see in the backends, we want to have those many directives. So let's go ahead and run this job on Nomad. Once we run this, it is going to be a one-time job, so we are going to run it once. The cluster is going to be configured and the job is done, right? So yeah, we should have that getting started in a moment. And you should see it running. There we go. So once it's complete, we can switch back to the Fusion Control Plane. And if you refresh the page now, we'll see that we have the new cluster called Nomad Dev1, as well as in the dropdown, we should see the same. Let's get a quick peek into the Nomad Dev1 cluster configuration. We can see the HAProxy license being added, the 2.8 version, In the membership section, we can see the generated bootstrap key, which is going to be pushed in Vault. Let's switch over to the Nomad Dev cluster here and go to the service discovery tab. So now we see that we have a console FCP provider of type console, of course. In the resources section, we see that we have 3 backend resources, one for each of the colors. Note that we do not have any nodes configured there yet. So inside these resources, we have the basic details like the name, the transformer type being backend, but also the prefix blue SN, which is going to be combined with the suffix that we saw earlier to name the backend, right? This is the same resource template that we fed into the bootstrapper, which appears here, and this is going to be used in creating the backend. But the most important aspect here among all of these configurations are the node filter tags. So we gave the node filter tag blue in this case. Fusion Control Plane is going to use this tag to filter out the nodes, filter out the Nomad nodes within console and populate the backends. We'll see that very shortly. Similarly, for green, we have the green node tag. And for red, we have the red node tag. So in addition to this part of configuration, the bootstrapper also pushes a bunch of static files, which we are going to use in the final HAProxy configurations, things such as the .htdp files, the CERD, the map file, and the Lua script. So among all of these, the most important one is the weighted backends.map. This ties back to what Dilpreet was explaining on how we are going to do the weight backend routing. In here, we provide a range of numbers that we are going to generate a random number for. And based on where it falls in this range, we are going to select the appropriate backend for routing the traffic. And lastly, in the infrastructure list, within the tab section, we do not see any nodes yet. That's because we are not running any load balancer. So that's our next step. We are going to run the load balancer HAProxy containers on Nomad. And to do that, we have another job, which we are going to run. We call it the HAProxy managed. This is of type system, meaning we're going to run one instance each on all the Nomad clients that satisfy a specific constraint. And in this case, we want to run them on node classes whose values are either red, green, and blue. So that's going to be pretty much all of our 9 Nomad clients. We're going to use the official HAProxy Enterprise 2.8 version container image. And to pull that, we are going to give the registry authentication details, which is going to be the license key. We are going to fetch that from Vault, as well as the bootstrap key. In this section, the bootstrap key, which the bootstrapper script had earlier placed in Vault, and it grabs it from the same path. Right? But the single most important block here is the service block, wherein Nomad instructs console to create a service entry called HAProxy managed and tag it with the value of the node class, which is going to be red, green, or blue. Right? So let's go ahead and run this. And also notice that the port sidecar is mapped to 443 on the host port, on the host network. So we're going to run this, and momentarily all the 9 instances of the HAProxy load balancer is going to come up. Make sure we have all of them in running state. And so we see the 9 allocations. So if we switch over to the console view, in the services section, we have the HAProxy managed service with the blue, green, and red tags available. Right? So notice that for all the Nomad blue clients, we have on the right-hand side the blue tags, and also notice the IP and the port being 443. Right? That is what HAProxy Fusion Control Plane is going to use to populate the backends. Right? Similarly, for green clients, we have the green tags, and for the red Nomad clients, we have the red tags. So in here, now we see that in the nodes list, we have the 9 Nomad clients auto-registered, right? Super cool. In the service discovery tab, if we go back here and look at the resources, we see that we have 3 nodes now, 3 nodes each for each of the 3 resources, right? In the generated view, so in the generated view here, if we sort the addresses here, we'll see that the same IPs appear for each of the individual 9 clients, as well as the associated port, which is 443 in our case. So we have the building blocks here, right? Let's go over to the config section and discover that we have the backends dynamically generated by Fusion Control Plane. And also notice the names, which is a combination of the prefix and suffix that we gave. right? In addition to that, also notice that we have the same directives that we provided to the resource template. In the servers list, 3 of them are going to be the 3 Nomad Blue client IPs along with port 443. And all the rest of these server lines are redundant localhost server lines, which will be replaced in the event we scale up the Nomad clients. Right? This is going to be the same concept for the remaining 2 backends as well. So with all of these so far, it is time to bring in the Clover-specific frontends and backends. But before we do that, let's grab the map file. We'll place it in a new tab for reference, because we are going to go back to the map file to look at how weighted routing works. So we'll open that up. And if we go back to the main configuration, we'll remove the global and the default sections, and we'll bring in the Clover custom configurations here. But notice that we haven't touched the generated backends, the blue, the green, and the reds, right? We're going to keep them as is. So brought in a lot of frontends and backends. Most of those are for the service mesh functionality, which are all egress from the application, right? But the 2 most important frontends among all of these are going to be the LB HAProxy frontend and the local cost frontend. The LB HAProxy frontend binds on any IP and listens on port 8080, which, if you go back to the diagram, it's at the very top here. It is load balanced by the GCP TCP load balancer across all the 9 clients on port 8080. In the GCP load balancer view, we see that the load balancer is receiving on 8080, and it has the 9 Nomad Blue client, all the 9 clients here listed, but none of them are healthy. That's because we haven't submitted our configuration yet, right? So when the request arrives at one of the 9 HAProxys on port 8080, HAProxy needs to decide which backend to pick, right? And it does so by generating a random number between 1 to 100 and look for that number where it belongs in the map files, right? So going back to the map file here, depending on which range it falls, the corresponding backend is going to be selected. So let's assume it's between 34 to 67, right? And based on our assumption, the blue backend is going to be selected for routing from the LB HAProxy to the backend. So the use backend directive sends over the request to this backend, right? And in here, among all the server lines, we know that we have the 3 IP, the valid IP addresses for Nomad clients, and the request on one of those Nomad Blue clients is going to arrive at the port 443. That is going to be the final node destination, right? So reiterating the same thing, request arrives on one of the 8080 frontends across any of the 9 clients, but then based on our assumption, it arrives at one of the 3 HAProxy 443 frontends on the blue client. From here on, the local cost frontend would have just received the traffic on one of the 3 blue clients, right? So we'll look at that local cost frontend. In here, it's listening on 443, and here is where we are going to do the SSL termination, right? Notice that the LB HAProxy frontend was a pass-through frontend, so it did not touch any of the SSL pieces here, right? Just came in and still encrypted. And at local cost, we are going to present the server-side cert, decrypt the traffic, and the decrypted request then arrives at the local cost backend. And the local cost backend is where we have the local host, and the HAProxy just sends the request to port 8020, which is where our cost application is listening on locally, right? So that's the lower part of the diagram, where the request from the port 443 frontend arrives at the 8020 cost application. So back in the configuration view, all the remaining backends and frontends help with providing cost with the service mesh functionality. All of those are egress from the cost application, right? So if cost were to talk to an application called Hierarchy, which is running in Kubernetes, it does so by making a request on the host's network local host and on port 18118. This works because both cost and HAProxy run on Docker's host mode, right? So all of those ports are unique to the frontends and unique to the applications indirectly, right? So HAProxy receives the request on port 18118 and forwards the request to the default backend in this case, which is going to be the Kubernetes Istio Ingress Service Mesh Hierarchy. In here, it has the It has the details to forward it, which is nothing but a Istio ingress URL, and Istio then takes care of routing it internally within Kubernetes. So with all of this, let's go ahead and submit the configuration. Once we submit and once it looks good on the Fusion Control Plane, it's going to push these configurations to all the 9 HAProxy load balancers running on Nomad. It's looking good. So if we switch back to the load balancer view on Google, now we see all of them are reporting healthy. And that's because 8080 is actively being listened by HAProxy load balancers, right? So to tie this all together and do the weight-based routing now, we'll come back to this, right? We see here that we have an equal 3-way split of traffic between the 3 colors. So in theory, if you were to make multiple requests to the load balancer on a specific endpoint, we should sort of see the rotation of requests being served by 3 different colors. So we have the COS-V1G as a very simple endpoint. We'll make that request against the client load balancer on port 8080, right? And we expect to see that version, the git commit ID version change, right? Right now we are seeing 10D7, which corresponds to the version running on COS red job, which is the 10D7 version, right? If you go back here and do a refresh, we're going to see that the version is changed to 976, which corresponds to the COS green version, as we can see in the COS commit hash here. And lastly, if we were to do another round of reload, we'll see that the version, the git server commit ID version has changed to 422A, which corresponds to the COS blue. So in this manner, we can potentially skew the numbers in favor of 1 or 2 of the backends to determine to send the traffic accordingly. This can also be extended to pin-specific customers by either placing the customer IDs, or that might be too much, so we can do customer groups and place the customer groups specifically here and route them to specific backends. So this concludes the demo.
Thanks, Vani. Okay, so the conclusion and the next steps for what we are doing here is Rainbow in deployment, as I mentioned earlier, what it allows us to do is ensure customer stability. It also gives us the ability to release code during normal business hours, because you can imagine a monolith releasing it in the middle of the day and not having the capability of rollback can be very hurtful for the organization. And we can release and test the release with incremental traffic to give us more confidence. And it also gives us more flexibility and options for multiple code bases with different feature flags deployed to the customers which are especially wanting a specific feature instead of rolling it out to everyone. And the next steps which we are trying to achieve in the future are automate our interactions with the HAProxy Fusion Control Plane. As you guys saw in the demo video, the map file was manually posted and the config changes. So all that we can automate so that we don't have to go and see the Fusion Control Plane. And all of the developers don't need to know where exactly to go and change the map files and stuff like that. And also we want to design a consistent application model for all of this. So you guys saw that Anirudh was posting Nomad jobs on the Nomad UI. We want to design an application model where the applications teams don't need to worry about where we are going to deploy. It can be Kubernetes, Nomad, a cloud function, whatever. And they don't need to worry about what we are going to do as platform team to deploy it. Yeah, this is just a small diagram. We are really running out of time for the questions. So this is what we just saw, and on the top of it, we have an application model. So right now you saw Ani doing the HCL format, deploying the Nomad jobs, and also playing with the HAProxy Fusion Control Plane. But in the future, if we have an application model, that would be the source where everything would be driven from. And the application teams have not to worry about what we are going to do behind the scenes to deploy the applications. So with that, I'm really hungry. So yeah, we can have Q&A, and then we can all go to lunch.
Great stuff, guys. Awesome job. So we probably, as Dilpreet mentioned, we do have lunch right after this. We probably have time for maybe 1 or 2 questions. So if you're in the audience, please raise your hand up high. We do have one right over here. And again, you can submit them on the stream.
Hello. I do have one question. I was wondering why you're using a random to to route the traffic from the 8080 to the blue, red, green, and why not using consistent hashing so that the traffic is even on the blue, red, and
That's one possibility too. It's just a way of picking one of the three by giving them the random, the benefit of randomness between the three. So assuming that the random is truly random or close to being random, we are going to fall in one of the three categories. So that sort of ensures that we have weights according to the numbers that we provided over there. But maybe hashing is an option too. Yeah.
We do have one on the stream. This is probably our last question. Which of the REST APIs are you using for managing Fusion, and are there any that you're investigating for the future?
So Fusion Control Plane exposes Swagger. If you look at the Swagger, we have tons of REST APIs for configuring the cluster, for adding front ends, back ends, even the console integration. Everything is driven by REST API. Does that answer the question? Yeah?
I think so. It was in the stream. So I think that's all the time.
Combination.
Yeah, that's all the time that we have. I would like to say a happy birthday to Ani. So this is a nice birthday present.
Thank you.
And huge thank you to both Dilpreet and Ani for your talk.